right, so we're just going to go through each one like the first step, just how it would start out. So for number one, this is going to just be a u substitution. U is going to equal the denominator. So that is how that is going to start. That would be like the first step for that. For number two, also just a regular u substitution, you would let u equal the stuff in the parentheses. So the 5x cubed plus 8. All right, number three, same kind of thing. You would let u equal the denominator. So the 2x to the 5th plus 7. Now, 4 is not going to be a regular old u substitution. Does anyone have an idea about number 4? You can't just let u equal this denominator. Then when you do the derivative, it's not going to all match together. Does anyone notice what pattern this one is? These are all jumbled up now, so I made it harder. But I'm telling you, it's not a regular u substitution. What is this one going to be, guys? Good, nice job, perfect. Good job, guys. This one's going to be arctangent. A would be 7, u would be 6x, and it's going to end up being arctangent. All right, cool, good job. All right, number 5 is one of these ones that you have to split. So you're going to split it into two separate integrals. So you'll do just the x over that denominator, and then just the 7 over that denominator. And you can even just put the 7 out front if you want to. In fact, sometimes that's a little bit easier if you just put the 7 and then just leave that as a 1 in there. So it's like a part A and a part B kind of thing. So the first part would just be a regular old u substitution. You would let u equal that denominator. And the second part is going to be an arctangent. All right, for number 6, you're going to let u equal the inside part. It's going to be a regular u substitution. You would have to think of a function that has negative cosecant squared as its derivative. Let me grab my flashcards because we haven't gone over that one. I'm going to need my flashcards. I hope you have made flashcards at this point. All right, number 7 is going to be long division. So hey guys, what number would go in the little box? I know this one printed a little blurry. I'm really sorry. Good, 3. It's whatever makes this denominator 0. So 3 would go in the little box. And then you would take the coefficients from the problem. So we have 1x to the 3rd, negative 2x squared, 5x, negative 1. You would do that long division and then put that back into the problem. All right, for number 8, u would be the inside part, so the 1/5 x. Tangent was one of those ones that you just had to plain memorize. So have you got some flashcards? All right, number 9. What pattern is this one going to be, guys? This is one of those patterns you have to notice. It's not going to be just like a basic u substitution. What is this one going to be, guys? Good, nice job, perfect. Arcsecant. It's got the square root, and it's got that extra little doodad out front, right? So a would be 7, u would be 4x, and this is going to be arcsecant. All right, number 10 would just be a regular u substitution. You would let u equal that inside part, like the guts of the problem. 11 is going to be arcsine. You would let a be 8, 8 squared is 64. U would be that x plus 1, and that's going to be arcsine. It has the square root, but it doesn't have the extra little part out front. 12 would be a regular u substitution. You would let u equal the denominator. 13 is going to be complete the square. So in the denominator here, we'll have x squared minus 6x, and then you have to divide by 2 and square. So you would take 6, divide it by 2, that would be 3, and then 3 squared is 9. You always add on, because when you square something, it's always positive. And then you just have to adjust that to what's in the problem, because you're not allowed to just go around changing the problem. So we have a plus 9. I need for it to be a plus 13, so we'll add 4. 9 plus 4 gives you 13. And so that would be something squared plus 4. The whole point is for you to be able to factor it. So that would factor into x minus 3, x minus 3. So that would be x minus 3 squared. And then it would be an arctangent pattern. So A would be 2, U would be the x minus 3, and it's going to be an arctangent. And then 14 would be a regular U substitution. You would let U equal the denominator. Now be careful, not many of these have boundaries, but some of them do. So if that's the case, make sure you actually do upper boundary minus lower boundary. If there aren't boundaries, make sure you put plus C. I will have to take off if you don't put plus C. So make sure you put that if there aren't any boundaries, okay? So I will now go over as many of these as I possibly can. So you guys just type in the chat which ones you want. I'll do them in the order you asked me. And then, of course, I will post the answers to all of them. All right, we're going to start with 13. All right, so I'm going to go with what's written here because I already did the first couple of steps there. So we completed the square, and we've got A is 2, U is x minus 3. So if we do the derivative of that, derivative of x is just 1. So that derivative is just going to be dx, which is nice because there's not an adjustment that you have to do. The only thing that's going to get highlighted is the dx. You can highlight that if you want to. So when you substitute, it's going to be du over u squared plus a squared. Again, if you want to skip that step, like if you just know it's going to be arctangent, you can just jump straight to the answer, but it is the arctangent pattern. And arctangent has 1 over a in front of it. So we're going to have 1/2 arctangent, and then it's u over a, so x minus 3 over 2, and then plus c. So again, to recap that one, we completed the square, and then it was an arctangent pattern. A was 2, u was x minus 3. That derivative is just 1 dx, so that's the only thing that got highlighted. And it's 1 over a arctangent u over a plus c. Right, the next one was 4, so let me jump back up here to 4. So this is going to be really similar to the one we just did because it's also arctangent, except this one's going to have an adjustment. U is 6x, so that derivative is 6 dx, and so we're going to need to adjust with a 1/6. So this one does have an adjustment with it. Again, dx is the only thing you get to highlight for that. And in its place, we're going to put 1/6 du. So you'd have 1/6 out front, and this is going to be du over u squared plus a squared, which again, if you just recognize that's arctangent, you're good to go. Just don't forget to put the 1/6. Again, this one had an adjustment. Derivative of 6x is 6, so we needed a 1/6 out front. So it'll be 1/6 times 1 over a, so that'll be 1/7 arctangent u over a plus c. And if you want to multiply these together, that would be 1 over 42. You don't have to, though. You can leave it just like that. All right, and then the next one I'm seeing there is 8. So let's go to 8 next. Again, stick with me, guys. I know going over a study guide is not like the most super fun thing in the world, but I want to give you all the answers, okay? All right, so we're on number 8. And this is one of the ones you would just plain have to memorize. Or you can rewrite tangent as sine over cosine. Remember, I worked that out for you. But I would probably just make some flashcards and know it. All right, so derivative of 1/5 x is going to be 1/5 dx. And so we have to adjust that with a 5. So in place of dx, we're going to put 5 du. So 5 goes out front, du goes at the end. What's still there is tangent of u. And hold on, let me find this flashcard. And when we were doing remember the Quizlet flashcards? These are on there, so you can always go back and practice those. All right, so antiderivative for tangent is negative ln cosine of x plus c. Now, I mean, it says x in there. In this case, it's a u because we did a u substitution, but negative ln cosine of whatever plus c. So this will be negative ln. Now there's a 5 out front, so it's going to be negative 5 ln cosine of u plus c. And the last step is to put the 1/5 x back in for u. So it would be negative 5 ln cosine of 1/5 x plus c. All right, and then 7 is the next one I'm seeing there. So I'm just gonna jump right over here to 7. I'm gonna rewrite what I have there though, because there's not very much space on that paper and I wanna have a little bit more room. So let me just recopy that real quick. All right, so we're gonna do synthetic division. 3 is the number that goes in the little box. It's whatever makes this 0, and then I just stole all the coefficients from the problem. So I'm gonna bring down the 1, and then it's multiply, add until you get to the end. So 3 times 1 is 3, add that column, and you get 1. So 3 times 1 again is 3, add that column, you get 8. 3 times 8 is 24, add that column, and you get 23. So when you go to put this back in the problem, put the integral and the dx there, you start with 1 less power than you had, and that's because you're dividing out. So this was x to the 3rd, we're going to start with x to the 2nd. X to the 3rd divided by an x is going to give you x to the 2nd. So this is 1x squared plus 1x plus 8, and then 23 is the remainder. So that gets left over the x minus 3. What you're saying is we were unable to divide that out. That's the leftover part. So 1x squared plus 1x plus 8, and then 23 is the remainder. And then you're going to do the antiderivative. So all that's like pre-calc, and then we have this one step where we're going to actually do the integral here. So this would be 1/3 x cubed plus 1/2 x squared plus 8x. And then this one, again, it's going to be ln. When you have 1 over x, that's ln. The minus 3, again, it's a constant. It's not going to change it. Again, if you have x squared or x to the 3rd or x to the 4th, this won't work. But as long as it's just x, then you're fine. And 23 is just going to be the coefficient. You could write that fraction as 23 times 1 over x minus 3 if that makes you feel better about it. It's just getting multiplied by a 23. So this is going to be plus. So it's going to be plus 23 ln x minus 3, and then plus c at the end. So you do the synthetic division and then do the antiderivative of what you get. And those are going to, if there's a remainder, you're going to have an ln tacked on at the end. It'll be whatever that coefficient is, and then ln of that stuff plus c. All right, so 12 is the next one that I'm seeing here. All right, so I'm going to use what's already written there. U is tangent of x. We need that derivative. Ooh, let me get out the flashcard. Derivative of tangent is secant squared, which is in the problem. You can use the problem to help you because these problems are helpful. It has to all fit together. So derivative of tangent is secant squared. 8 is a constant, so that's gone. There's no adjustment, that's it. So we're replacing secant squared of x dx. And so what's left is 1 over u du. And so that antiderivative is ln. And then you just have to put this statement back in for u. So ln tangent of x minus 8 plus c. All right, and then next I'm seeing is 5. So let me go back to number 5 here. All right, so I already split this. For the first one, it's going to just be a basic u substitution. So du, this derivative would be 2x dx. And so I'm going to adjust that with a 1/2. So in place of x dx, we're going to put 1/2 du. And what's still there is 1/u. So that antiderivative is ln. I'm not going to put plus c yet because I'm going to wait till I finish the second part. I'll just tack the whole thing together, put plus c at the end of all of it. I just need to put this x squared plus 81 back in for u. All right, so that's the first half of the problem. Now we're going to do this one, which is going to end up being arctangent. U is just x because it's just x squared. So what's nice about that is du is just dx, and there's no adjustment that's needed. So this is going to be plus 7 integral du over u squared plus a squared, which is the arctangent pattern. So this is going to be 7 times 1/a, which is going to be 1/9, or you can just write 7/9 arctangent u over a, so that'll be x over 9, and then I'm going to put plus c at the end of the whole thing. So I'm just tacking those two answers together. So we split it and did it kind of as a part A and a part B. All right, I'm through the ones you guys put in there. Can I make a suggestion that we do number 6? Because that involves some unit circle here. That's my suggestion. Yeah, let's go ahead and do number 6 next. Hold on, I just need to grab another piece of paper. And actually, this is going quickly. I might end up getting through all of them. We'll see what happens. All right, so number 6, we're going to let u equal the guts of the problem, that inside stuff, so 5x. So the derivative of that is 5 dx, and we're going to adjust with a 1/5. So dx is the only thing that we get to substitute out. And in its place, we're going to put 1/5 du. So it'll be 1/5 at the front, du at the end. And I'm trying to look back how I did this one when I posted it. I adjusted the boundaries for this one. All right, so inside, what's still left is negative cosecant squared of u, and we're going to adjust the boundaries. So I'm going to plug them in right here for x. They're just getting multiplied by 5. So instead of pi over 4, that's 5 pi over 4. And instead of pi over 2, it's 5 pi over 2. So now we need to do the antiderivative for negative cosecant squared. Let me find this flashcard. Hold on a second. So it is going to be cotangent. Derivative of cotangent is negative cosecant squared. So if we go backwards, we're going to just get cotangent. And I even put the negative in there for you and everything, so you don't even have to adjust it for the negative. So this is going to be 1/5 cotangent of u, and then we're going to evaluate. And you don't have to plug this back in because we adjusted the boundaries. All right, so upper boundary minus lower boundary. So it would be 1/5 cotangent of 5 pi over 2 minus 1/5 cotangent 5 pi over 4. All right, so let's find this on our unit circle. Let me pull out my unit circle. So we want 5 halves. You can just count around the circle in halves. If you go, this is where you're starting. Okay, follow me on this. All right. Up here is pi over 2, that's 1/2. Over here is a whole pi, that's 2 halves. Down here is 3 halves, 3 pi over 2. The whole way around is 4 halves, just 2 whole pi. So if you keep going, 5 halves is going to be right here. So it's going to be in the same place as pi over 2. Let me count that out again. This is 1/2, 2 halves, 3 halves, 4 halves, 5 halves. So we're right here. All right, then you have to remember what cotangent is, how you get that. Cotangent is x over y, so it's 0 over 1, which is just 0. So this entire thing is just going to be 0. 1/5 times 0. Minus, and we've got to find 5 pi over 4. So let me draw this for us. Now, 1/4 would be right here. I'll count around for this again. Like pi over 4 would be right here. That's 1/4. This would be 2/4. 3/4 is right here. 4/4 is 1 whole pi. And so 5/4 would be in the third quadrant. So our triangle is going to be right here. And what are the sides when you have fourths? When it's pi over 4 is your reference angle, these are both going to be the same. What are they both going to be? For pi over 4, guys. Good. Yeah, I know it's tough to type in the chat. Sorry. Yes, good. So you guys are doing a good job. All right. Root 2 over 2. Also, they're both going to be negative since we're in the third quadrant. All right, cool. All right, so this is going to be 1/5 times cotangent is x over y. So anything over itself is going to just be 1. Everything cancels, including the negatives. And so this final answer would just be -1/5. So it's 0 minus 1/5 times 1. So just -1/5 for the final answer for that one. And then the other one I'm going to suggest, since no one has typed in anything else, is number 10. Let's look at number 10, because that has a square root in it, and that always kind of throws people off. All right, so number 10, we're going to let u equal the guts of the problem, that inside stuff. So that derivative is going to be 8x dx. And so we're going to need to adjust with a 1/8. So we're going to highlight the x dx. And in its place, we're putting 1/8 du. So 1/8 goes out front, du goes at the end. And what's still there is square root of u, but it's in the denominator. So because it's a square root, that would be u to the 1/2. But because it's in the denominator, that would be a -1/2. And in the denominator means it's been divided, so it's a negative exponent. The 1/2 comes from the fact that it's a square root. And then we need to adjust the boundaries. So I'm going to plug these in. So if you plug in 0 for x, you're going to get 8. And if you plug in 3 for x, all right, let's see, 3 squared is 9, times 4 is 36, plus 8 would be 44. I'm just making sure I added that right in my head. Yeah, 44. All right, so antiderivative, we've got this 1/8 out front. You're going to add 1 to the power. So -1/2 plus 1 would be a +1/2. And then we'll need a 2 out front. No plus c, it's going to be such that 8 to 44. And then it will be upper boundary minus lower boundary. Now you can leave it as 1/8 times 2 if you want, but that would be 2/8, which would be a 4th. I'm just going to go ahead and write that as a 4th. And then this would be plugging in 44. You could write 44 to the 1/2 if you want, but that means square root of 44. And then minus a 4th, this would be 2/8, so a 4th, and then you're plugging in 8, so square root of 8. And you don't have to simplify that any further. You can just leave it, again, like I said, you could leave it 44 to the 1/2. You could leave this 8 to the 1/2. I just think this looks nicer. So that's how So yeah, 6 and 10 were the two that I wanted to make sure I went through. I have a little bit more time if you guys want to pick another one. Okay, 11. Oh, good. 2 people said 11. Great minds think alike. All right, number 11. All right, so we have A is 8. 8 squared gives you 64. U is x plus 1. And so that derivative is just dx. Derivative of x is 1. And then 1 is a constant, so that's gone. So the only thing we're getting to replace is the dx. With the arc ones, dx is generally the only thing you get to highlight, unless there's like they throw a number in the problem, like there's a 7 there or something. All right, so this is going to be du over square root a squared minus u squared. Again, if you don't want to write that, as long as you recognize its arc sign, you're fine. Arc sign does not have that 1 over a out front, so I'm not going to put that. It's just going to be arc sign u over a, so that's x plus 1 over 8 plus c. And then number 9. So we have u is 4x, so that derivative is going to be 4. And then we're going to adjust with a 1/4. So in place of dx, we're going to put 1/4 du. And this is u square root u squared minus a squared, which is the pattern for arcsecant. So out front, we've got that 1/4. This is the one time I say you might want to write this out, is if there's an adjustment, because I'm always scared people are going to forget to put the 1/4, which is like a silly little thing. You're going to be upset if you lose points over that. So 1/4 and then times 1 over a, so that'll be 1/7 arcsecant, and then u over a plus c. And arcsecant has the absolute value around that. If you forget that, I'm not going to take off because, I mean, it's such a little thing. And if you wanted to write this as 1/28, you can as well, if you want to multiply those fractions together. I think we did nearly all of them, didn't we, guys? I think except for maybe the first couple and the last one. Let me do 14 and then we'll end with that. Because 14 has boundaries on it. So let me do number 14 and we'll end with that one. I think the only ones I didn't do were like 1, 2, and 3. And that's good. Let me leave those for you and you can save those for extra practice. All right, so we have u is x plus 3. That derivative is just going to be dx. And so I'm going to bring this 9 out front. I'll put that in front of the integral. So it'll be 9 integral 1 over u du. And then we're just going to adjust the boundaries. So if you plug in 8, you're going to get 11. And if you plug in 12, you're going to get 15. And so this antiderivative is ln. And you do not need to plug this x plus 3 back in because you adjusted the boundaries. So you get to skip that step. And then it's upper boundary minus lower boundary. So this will be 9 ln of 15 minus 9 ln of 11. That looks kind of funny with an 11 there. I'm going to put some parentheses. And you would just leave that. The only ones you can do without a calculator are, actually, let's review those. The only ones you can do without a calculator are ln of e and ln of 1. So hey guys, what's ln of e? These are the only two you could do without a calculator. Other than that, you have to leave them alone. But what's ln of e? Because they cancel. Good, nice job, guys. That one's 1. Because they just like undo each other. And then what's ln of 1, everybody? You guys are ready with that answer because you knew it was coming. Those are the two you need to be able to do without a calculator.